In this session, we're going to learn something called counting. What is a typical counting question? For example, in Virginia, okay, in Virginia, and usually the car tag plate comes like this: A, B, C, 1, 2, 3, 4. You probably have seen this a lot. This is a car tag plate. It comes with this three letters and then followed by four numbers. Of course, you can customize your own tag plate, but if we set up the rule like this, how many possible car tag plates are possible? How many different tag plates are possible? And that's a very, very typical counting question. Okay, so what we do is we look at the first place, the second place, the third place, fourth, fifth, sixth, and seventh. So there are 7 places we have to put things there. And then we just find how many possibilities are here, how many possibilities are here, and so on until the last one. And then we multiply all those numbers, which is for the letters, that's from A to Z, so there are 26 of them. And then the second place also has 26, and the third 26. All right, and then this could be 1 all the way to 9, and on 0, so there are 10 possibilities. And here 10 and 10 and 10 and 10. If you use calculator, guess what? You get a 26 times that, so you have this number. You have a 1 7 5 7 6 0 0 0 0. So that is 175,760,000. That many possible outcomes. And do we have that many cars in Virginia? I don't think so. I think Virginia we only have around a little bit more than 8 million people. So yeah, we should have plenty to use. All right, so this is very, very typical possibilities. And you use this a lot. You probably can think like the combination log. The combination log that has like the wheels of, I don't know, like a four wheels, and each one comes with a number like a 0 to 9, and how many possible outcomes are there. The combination log, right? So it was like this. All right, so the first digit could be 0 to 9, and the second digit also 0 to 9, and so on. So how many possibilities? 10 times 10 times 10 times 10, which is 10,000 possible combinations are there. And actually they are from 0000 to 0001 and then all the way to 9999. So that is this 10,000 possible outcomes. If you have like the combination wheel that has only 3 numbers, then that's going to be 1,000. Because sometimes you see, oh, I forgot the combination. Spend some time, try that one by one. It should be pretty quick, okay? It doesn't take very long. I'm not teaching you how to break other people's combination log. I just tell you how many combinations that you would know. All right, now, so that is the combination. And in mathematic way, we're going to say this. For a sequence of the events in which the first event can occur n1 ways, the second n2 ways, and the third n3 ways, and altogether the total number of outcomes will be n1 times n2 times n3 and all the way till the last. I don't know how many altogether. So this is called a multiplication counting rule. Multiplication counting rule. So that's the first thing we learn when we learn about counting. All right, now the next, after we learn this, I'm going to teach you something interesting. It's called a factorial rule. Before that, we have to know what is a factorial. Okay, that means how many different ways that you're going to arrange n things. How many different arrangements that if you have like 5 letters, how many different ways you can arrange them. If they have the letter 1, letter 2, letter 3, now I should put that A, B, C, D, E, then how many different ways you can put them in one string, like A, B, C, D, E, A, B, C, E, D, A, C, B, D, E, it's all the different ways to do that. So we have to learn something. This is called a factorial rule. We use n factorial. Okay. When you read this in English or in sentences, you probably use that as the emphasize, and you say n, right? But here, the n factorial, it's a special math notation, which means n times 1 less than that times 2 less than that times all the way to 1. You stop at 1. You stop at 1. All right, now quick calculation. Okay, quickly. What is a 3 factorial? That would be 3, starting from this number, multiplied by 1 less. When you go to 1, you stop. So that answer is 6. Okay, so 2 factorial, that will be just 2 times 1. You stop at 1, so that's 2. What about a 4 factorial? That will be 4 times 3 times 2 times 1, which is 4 times 2, which is 12 times 2, which is 24. Okay, or did you notice that the 3 factorial is actually 3 times 2 factorial, and the 4 factorial is 4 times 3 factorial, right? They're pretty much the same thing. Okay, now quickly, 5 factorial, which will be 5 by 4 by 3 by 2 by 1, and this is the 4 factorial, which is 24, so that will be 5 times 24. If you know this already, you can quickly get 120. So in this way, you can find for any number, you can find the factorial of it. And I'm 100% sure that if you pull out your scientific calculator or the one you pull out from your phone, they have this function, like either some of that use n factorial, some of that use x factorial. So you can just do it. In some calculator, you enter the number. Let's say you enter 4, and then you hit this button, hit this key, you get the answer. And some calculator, you might have to hit this first and enter that. I don't know. So double check with your calculator, make sure that you know how to do it. By definition, 0 factorial is 1. This comes by a special definition because it doesn't go with the original definition. Okay, you probably have noticed that if you like, you probably see that when you enter 1.5, not an integer, you put in 1.5, then you hit this factorial function, you can also get a number. That is very interesting. I'm not going to the detail about that. In this session, we only deal with 0 and all those all we call this is a whole number. We only do that. So first of all, we know what is the factorial rule. What does that mean? I'll give you an example. Okay, let's see. Some words consist of letters, right, which can be arranged to form other words. Let's say this one, steam, S-T-E-A-M. You probably have played this game. I give you these 5 letters. Let's see how many different ways you can arrange that. Okay, how many different ways can all the letters be arranged? We got a 1, 2, 3, 4, 5. No repeats. Did you see that? S-T-E-A-M, no repeats. So how you can arrange that as S-M-E-A-T, smeat, or meats, or all the things. Even something doesn't make sense. T-M-S-A-E, even something like this doesn't make sense. It doesn't really matter. I just ask you how many different ways you can rearrange these 5 letters. That will be 5 factorial. Okay, we know 5 factorial is 120, right? There are 120 ways. The other way to think about this question is how many ways you can put the letter in the first place. There are 5 of them, right? Could be S, could be T, could be E, could be A and M. So there are 5. And once you put a letter here, and that letter cannot be reused. So for the next place, there are 4 ways to put in, because you have 4 letters left. And then after that, you have 3 letters, you have 2 letters, and the last one you have only 1 choice. So you multiply by 5, 4, 3, 2, 1. You multiply all those 5 numbers, you get 120. Now you see what this factorial actually be used. Isn't it interesting? Okay. So what is the so far that's how many possible, that's how many different ways, that's 120 ways, this many ways this can be arranged, okay, there's 5 letters. Okay, now let me ask you the second question. This is the first question, this is A, and the B question. Out of this 120 ways, what is the probability that the letters will be in alphabetical order? In alphabetical order, so that will be what? That will be A, E, M, S, T. This is the only one that is in alphabetical order. So therefore, the probability that is in alphabetical order, the probability of that will be just 1 out of 120. That's your answer. You can just leave that as a fraction if you get something like this. Okay, so this is a very, very good way to think about the factorial or the counting, right? Okay, let me give you a hard one. Instead of we have the word STEAM, let's do this, stats. Or this is a short for statistics. How many different ways you can rearrange this 5 letters? Hey, be very careful. Did you see this T and this T? They're the same. This S and this S, they are the same, right? First of all, you can treat them as a different. This is S1, this is S2, this is T1, this is T2. So how many possible combinations? There will be 5 factorial. That is 120, right? But out of this 120, there's a lot of repeats. For example, I call this 1, 1, 2, 2. Okay, I just have a very, very tiny little note. This is the first, this is the first, and this is the second, this is the second. Okay, sorry, this is the first. And then if I put this T and this T, if I switch them, I do get exactly the same arrangement, right? So that means I repeat. So in this 120 of them, there's some redundant. I have to get rid of them, or I have to find how many repeats are there. So for S, there are 2 letters. So this S and this S, S1, S2. How many different ways you can arrange this 2 S's? So 2 factorial, right? Could be either this or this. So there are 2 repeats. And for T, it's the same thing. So the answer will be 5 factorial divided by the number of this and divided by the number of the repeats of another letter. So that will be 120 divided by 2 factorial, which is 2 times 1, and 2 factorial is again 2 times 1. So the answer will be 30. It's much less than 120 because we do have we do have repeats. Now let me just do the other one. College, C-O-L-L-E-G-E. C-O-L-L-E-G-E. So how many different ways you can arrange all the letters? 1, 2, 3, 4, 5, 6, 7. So I have a 7 factorial divided by, we have only 1 C, we don't need to worry. We have only 1 O and 1 G. We don't worry about that. But for L, for E, okay, so that's how you do it. Okay, that's how. Of course, you can just go ahead and find out, which is a 7 by 6 by 5 by 4 by 3 by 2 by 1 divided by 2 times 2. And this get canceled out. So you're going to find out how much is that. let me just grab my calculator to find it, because I don't have that out of my head. So 7 by 6 by 5 by 3 by 2 by 1. So it's 1260. That's your answer. Okay. So what about a more complicated situation like statistics? How many different ways you're gonna rearrange all the letters of this word to make up whatever new word or new way? It doesn't matter whether it makes sense or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will be 9 factorial. Okay, and then divided by, let me see what's the repeat. For S, we have a 1, 2, 3. So that's S. For T, 1, 2, 3. Okay, for A, it's just 1. So you can write a 1 factorial here, but you don't need it. And the T already considered. For I, there are 2 of them. And that's it, right? S and T were already considered, and I already considered that, and the 1C we don't really care. So that is the answer. Of course, you're gonna go ahead and find it. What's the final answer? And I'm not going to do this, and I hope that maybe you can just spend some time to work on that. So far what we learned is counting. Okay, we learned 2 rules. One is called multiplication counting rule. Multiplication counting rule. And then we learned the factorial rule. Okay, after this rule, we learned how to figure out like how many different ways you can rearrange the letters if there's no repeats and if there's some letters repeats. So what are you gonna do? All right, so this is what we learned for the counting part.